So, following on from yesterday, so we were talking about adding and subtracting decimals, and then we went on to multiplying and dividing. So I want to just recap very quickly. So, do you remember we were adding our decimals together, and we said it's very important the numbers with the same value get added together, right? So that's why we went, well, it's important that we get away from this moving the decimal point. The decimal point should stay where it is, otherwise you get confused. Remember we went through, well, adding, even if it's a negative decimal, same rules apply. So adding a negative is the same as subtracting. So we did that. This was one from your homework that caused a little bit of an issue in that we had to actually carry over, alright? Right, what we then started to look at, and this is what we're going to do more of today, is about multiplying decimals together. Alright? So, do you remember what I've written there? Could anyone explain it?
I do not remember.
Go on then, Margie.
Okay, so I think that the reason, why that was wrong, or what
was wrong?
Okay.
This one was wrong, but we went through this method. Can you remember the method?
So
I tell you, let me have do another one. Let's see whether you can remember the process. So if I did 0.4 times 0.3,
okay.
Can you remember the method?
Can
Okay, go for it.
I? Okay. So what I remember was that like, oh my goodness. Okay, so I did this wrong, so I'm just gonna redo it because you could do this, and that would be 12. That would just be 1. And that would all just be 0. 0. And
Okay.
0. But the thing is that since this is like the 10, well, this is the units.
Yeah.
But it's still like 0 points. So wouldn't you like move it like?
Well, that's moving the decimal point again. So it's like.
Wait, can I check?
Well, just let as you finish off a minute. So you would like to move the decimal point. I'm trying to get to avoid it. So the method that I gave you kind of avoided the whole moving the decimal point.
Yeah.
Just can you see how by moving it, it kind of messes the whole diagram?
Yeah.
So the column. Yeah, go on, erase it. I think you can do a big circle around it, and I think maybe not. No, it doesn't work on this one. Right. So that method, the column method, didn't work. But I offered you another method. At the end. So, have you got a different method, or are you going to do the same thing but again?
No, I was going to do like similar to that, but get a different.
Go on then.
That's a 2.
Thanks. Pass it over. So Moran's going to have a go. Remember, think about what she's doing, and
I think.
hang on, because your fingers touching. Hang on. Okay. She's not explaining. Does anyone think, is that the same method again?
Yeah.
Aren't you doing the same thing?
But then when I get the answer...
Yeah, but I don't want an answer. What I'm trying to avoid, Cameron, stop writing on Abby's book. Okay? What I'm trying to avoid with you is you just do this at the end. I don't want you to rely on things like that. I want you to have a method that you understand why it works, why you're allowed to do it, and that kind of thing. So I'm trying to avoid the whole or you just do this at the end. Because you won't be able to explain why. Make sense?
Yeah.
Go on.
Will this be on our test?
It will be on a test at some point.
Oh, okay.
Right, okay, Ron, thank you. That method is not necessarily working for us. So let's not. So what I'm going to do, I did this last time, and I would like you to see again, because we did it at the end of the lesson, and I want you to focus on what I'm doing, and you can write it down afterwards. All right? But I want you to ask if you don't understand what I'm doing. I really want you to. So don't write. Don't get all your different coloured highlighters out just yet. Right? Because that's more of a focus for some of you than the actual doing what we're doing. Do it afterwards. So ask at any point if you don't understand why I've done it. So with numbers, we can write things that mean the same thing. So for instance, I can say that 0.4 is the same thing, that's what an equal sign means, as 4 divided by 10.
Oh, I remember this one.
Yeah, so what we were doing is, we're saying, actually, stop right.
Oh, sorry.
What we're saying is, right, we're getting rid of the decimal and we're turning it into something else. So 0.3 is the same as 3 divided by 10. Okay? So what I can do then is transfer it over to here. So 0.4 is actually 4 divided by 10 times 3 divided by 10. Now, what I then said was we did this again with the adding and minusing. I'm going to block it off with saying, right, the 4 goes there, the divide by 10 goes together, the times by 3 goes together, and the divide by 10. Okay? Does that make sense? So now it's a series of operations. Now what I'm going to do is I'm going to rearrange it. Do you remember we said before as well that multiplication and division, if that's all there is, can be done either way round? Do you remember that? So I said 8 times 4 and divide by 2. Is that the same as 8 divide by 2 times 4?
Yeah. Yeah.
Yeah? Okay. I'm sure you're happy with that. Both of them are 32, yeah? So I can do that. If I do a times followed by a divide, I can equally do the divide followed by the times. So I'm going to do that here. I'm going to rearrange it. So I'm going to do the 4 times the 3. So what we've done now is we've just taken the numbers but not as decimals. We've just treated them like numbers, whole numbers, integers. But then, whatever that result is, I'm going to divide it by 10 once, and then I'm going to divide it by 10 a second time.
Wait, can you just merge the tens together and then divide by 20?
Oh, okay. Well, let's talk about that. Can we put them together?
Divided by 100.
Okay, that's better, isn't it?
Yeah.
Divide by 100. Okay. And what's 4 times 3? 12. Now you see we've got to do 12 divided by 100, and so my answer is 0.12.
Cool. Oh, so then the ends would be 0.1. That's how big my hand. What was my answer?
Say again.
That's why you didn't pause it.
No, I wanted your question on the... So what we've got now is we've got a method that works, and you're not saying, oh, just do this. You could explain why 12 divided by 100 is 0.12. Because we've done all of that, haven't we? Well, it's the same thing, because algebra is just numbers that you don't know yet. Yeah? So we're trying to get away from that whole, oh, you just moved the decimal point this moment. Okay. Now, to see whether you truly understand, what I can do is give you a different one. So I can say, afterwards, after you've written this, maybe you can answer 0.5 times 0.04 and see whether you can work that out, Sven. So let's go through them. Would you like to talk me through the first one?
Sure. Can I bring up my book? Okay, so what I did was 0.5 0.5 equals,
We're going to run out of room.
oh,
But come on.
well, it equals 5 divided by 10,
Yeah.
and then the same with, that one equals 0. Oh my goodness. 804 equals 4 divided by 100.
Yeah.
Okay, so,
Let me just rewrite that
okay,
using what you've done to give more space.
okay.
Right? So you have just written that 0.5 is equal to 5 divided by 10
Mhm.
and 0.04 is equal to 4 divided by 100.
So that's just like giving you the basics of like.
Yeah.
Okay, so then you would take this information and you would do 5. Let's just cut this part out.
Yeah.
So, and cut this part out. So 5 divided by 10 times 4. Oh my goodness.
Oh no, it's going to stop. This is bad.
So this would be there. Okay, so then this would be on its own. Then this would be on its own. And then this would be with that. And then this would be on its own. So then what you would do is you could move this to make it 5 times 4 divided by 10 divided by 100. But you can merge these two together, which equals 1,000. So there. And then you could do 5 times 4, which equals 20, divided by 1,000, which equals, 0.02.
Okay. Good. All right. Let me just rewrite. Yeah, go on. You can do the next one. Let me just tighten that up a bit. So perfectly good. So we did 5 times 4 makes 20, and then the divide by 10 and the divide by 100 become divide by 1,000, which gives us an answer of 0.020. But we could leave the 0 off and just write 0.02. Good. Good? Cool. Go ahead.
So, this 12 would just remain the same because
Yeah.
it's not a decimal. And then this would be 1 divided by 100.
Yeah, go for it.
And then, so that's 12 times, oh, wait. You could do 12 times 1 divided by 100.
Yeah.
And then that's 12.
Try not to touch it with your hand.
12 divided by 100.
Yeah.
And then that's 0.12.
Cool.
Yay.
Great stuff. Go on then. Yeah.
Okay,
Careful.
I'm pausing. Okay. Okay. 24 stays the same.
24 stays the same, yeah?
Yes.
Abby, why have you closed your book? You're the one person I think probably needs to keep the same.
Then 0.2 is just 2. 0.2. Let me just write this down. Passes.
Yeah, 2. You try not to touch it with your.
I'm not touching it.
Go on, go for it. We'll finish this off.
I'm not touching my hand. That's the thing.
Shall I do it? Really tell me, I'll do it quickly. So 0.2 is,
Equals 2
that's 2
divided by 10.
divided by 10.
And then,
So we've got 2 divided by 10 times 24, Abby.
Yes. So then you just.
So we do 2 times 24.
Divided by 10. Means 2 times 24 is 48. Divided by 10 is 4.8.
It's 4.8.
Oh, I did 2 divided by 10 times 24.
Well, that's what you had to start with.
I took the board pen with
I
me.
know. So cute.
Sorry, Cameron.
Okay? Make sense?
Wait, I'm writing the actual answer.
We'll finish.